will be a little bit of reteaching. We're not going to do all of them. But some of you, by looking at your homework, still were struggling with the 3 binomials. Okay? Remember, standard form is in descending exponent order. So if you're given it in factored form, you can convert it into standard form by FOILing. Okay? And using the distributive property. So you have to FOIL 2 of the 3. You can either FOIL these 2 or FOIL these 2. My suggestion is usually to FOIL the last 2. You don't have to, but that's the 2 I suggest. The first one will stay as is. The second one gets FOILed. X times x is x squared plus 3x plus 2x plus 6. So this would be the work you would show on a homework question like this. Combine your like terms first. Then, you're not really FOILing from here because it's not going to be first, outer, inner, last, but you're distributing. So you're going to take the first term here, x, and you're going to distribute it to all 3 terms in the second set through multiplication. We'll get x cubed plus 5x squared plus 6x. Then we'll take and distribute the positive 1 to everything in that second set as well. So we'll get plus 1x squared plus 5x and plus 6. The last thing then is to combine your like terms and write it in standard form. So I'm going to bring the x cubed down first because that's the biggest exponent. We have 5x squared plus 1x squared is 6x squared. 6x and 5x is 11x. Cubic polynomial with 4 terms. We don't have to, but. So on your homework tonight, when you see problems like this, if you don't have work shown to support this and you just have an answer, you will not be receiving credit tomorrow. If you use scratch paper, make sure you have it to show me if you'd like to receive credit for problems without showing work on the actual worksheet. All right, B we're not going to do, but just if we were to start this, when you have that squared, make sure you expand it. And this would become x plus 1, x plus 1, x plus 2, and then you would do everything we just did on the other problem. But due to our delayed schedule, we will omit that question. All right, now, in example 2, we're going to switch gears. I'm going to give you standard form and ask you to write it in factored form. Okay? So as I said, factoring is not going away in chapter 6. It's actually going to come on even stronger than it did in chapter 5. So when you're factoring, the first thing you want to look for is a GCF, always. If you have one, take it out. What's the GCF for the first one? 2x. Remember, when you take it out, you're unmultiplying it, which means you're dividing it and putting it out front. Do not get rid of it. It has to stay out front of a set of parentheses. So inside we will get x squared plus 5x plus 6. Now before you circle that, always see if you can factor further. Can we factor the trinomial into 2 binomials? Yes. Yes. This is an easy factoring problem because a is 1. So you're just thinking what numbers multiply to be 6 and add to be 5. Add to be a positive 5. 3 and 2. Doesn't matter which order you put them in. This would be factored form. Circle your answer. Okay, the next one, GCF would be x. So again, we're dividing each thing by x. We'll get x squared minus 25. Can we factor that further? Makes this? Good, this is our difference of squares. One positive 5 and one negative 5. We're also going to be learning a difference of cubes. Way to factor with cubes is chapter. All right, see if you guys can do C on your own. Who can tell me if they got us their final factored form? Final factor. Oh, this one's harder. Maybe some of you are still working, I apologize. I expect you to still know how to factor. This will be the first and last time I'll review the factoring. Pay attention. When we see that A is not 1, this is where you have to use your guess and check method. So the 3x will stay out front. Set up your template for 2 binomials. You need these 2 terms to multiply to get you 2x squared. Your only options are 2x and 1x. So that's not really guessing. Sometimes you do have to play around with it. That's a guarantee. Now, guess and check is your factors of 12. These 2 numbers have to multiply to get me a negative 12. So that could be negative 1 and 12, negative 2 and 6, negative 3 and 4, or putting the negative with the other term. Now, you're not saying which of these adds to negative 5. You're saying when I FOIL this, which one of them is going to get me negative 5. So you literally just have to guess and check until you plug it in. So if I start with 12 and 1, again, when you check your FOIL, you really only have to check the outer and the inner. So you would get 24 minus 1, which is 23. That's definitely not right. We erase. Go to another set. Let's try 6 and 2. That's not going to work. 6 and 2 the other way will not work. Let's try 3 and 4. So this will get me 8x. Minus 3x is 5x, but it wouldn't be negative, so I have to switch my signs around. So that this will be a positive 3 and a negative 4, which this will get me a negative 8x plus 3x, which is a negative 5x. You have to know how to factor. You have to know how to factor in a reasonable time frame. Meaning, you can't take 10 minutes to factor that problem, or I can guarantee you, you will not complete your test. So if you are still struggling with factor, Google Classroom still has all your factoring practice. I would go on and just do them until you get faster and better at them. Because we are going to be factoring this whole chapter. We'll get to quartic and quintic functions, which will just make it even harder. That should be our final answer. 3x, don't forget about that, 2x plus 3 and x minus 4. All right, we're going to skip over the word problem for now, because I want to make sure we get to the other problem, just because of your homework assignment. We are definitely coming back to it either today or tomorrow, so don't cross it out. But go to the next page in your packet, and we're going to do these graphing calculator questions, because you do like that on your like this on your homework. All right, so before we were looking at quadratics, and quadratics would have an actual maximum, or they would have an actual minimum. When you're doing cubic functions, you're going to see that the curve will look like this, where it comes down, it goes up, and then it comes back down. So these are called relative mins and relative max, because the max is really infinity because of the arrow. But since it dips down and then goes back up, this is called your relative min, and this is called your relative max. Now the book only has you do the y value. If you prefer to write it as an ordered pair, I don't care. But it's really just the y value that it reaches, a min and a max. The zeros, you'll remember from chapter 5, are also called the x-intercepts. And that's where the curve crosses the x-axis. Those can be found by factoring. That's what we actually find when we factor and set equal to 0. Or you can use your graphing calculator. Now the problem with these ones is we are going to have to modify our window for some of them, because we won't be able to see the picture very well. So let's go ahead and type our equation into our y equals button. You guys can start doing that while I'm loading up my calculator. Now to get cubed, you're either going to press caret 3, or if you press the math button, there's a third exponent that you could choose. There should be, but there's not. Okay, so going to our y equals, clearing out that big equation we had from last week. And of course, make sure you type it in correctly, because if you type it in wrong, then everything else will be wrong. Now, who remembers what we like to press under the zoom feature that will give us a standard window? Zoom 6 standard, it's in your notes. Zoom 6. Okay, pretty good picture, right? The only thing I can't see is this little max right up here. So do not play around with the zoom button, because a lot of times you guys know it gets too far away or too close. So when this happens where you're just missing the peak, you will want to adjust the window. Oops. So we're going to press the window button, which is right in that top row. Now you have to logically think, what value do I want to make bigger, my x-axis or my y-axis? Look at the picture. To be able to see higher up, which do I want to make bigger, the x max or the y max? This is my x-axis. This is my y-axis. The y max. I need to change my y max to be higher up. So press window, arrow down, leave everything else the same. The y max is set to 10. I don't know what to change it to. I'm going to guess. Let's say 20. You could get crazy and go 50. I don't know. Let's see. Press the graph button. Do not re-press zoom 6. And that was good. Changing it to 20, that was able to give me like the whole picture. Okay. Now, we have to do the relative max, relative min, and the zeros. You may want to sketch this graph on your paper just so you can take notes on it. Okay. A lot of button pressing about to come up. You've done all these things before, but you haven't done them all in the same problem. So to find the relative max, we're going to press second trace, and we're going to choose the option that says maximum. So I'm going to do my relative max first, which is this peak of my graph. So second trace, choose option 4, which is maximum. And this is where it asks you left bound, right bound, and guess. You need to take your cursor. So here's where I want it to be. That's where the point I'm looking for. If you want to be to the left of that, you hit the left a couple times so that you're somewhere over here. Doesn't matter where. Right bound is to the right of the max. So we're focusing on just this point right now. Hit enter. You'll see your 2 little arrows pointing in. And then your guess, you're going to get as close to that peak as you can and hit enter. Okay? Now, it really just wants the y value, but if you would like to put it as an ordered pair, you can. Let's round this to the nearest hundredth, so 12.24. Again, if you'd prefer to write it as an ordered pair, you can. Okay, so we modified it. You have a negative instead of mine over there. So it's like shorter. All right, now to get the min, so this was our max. We did left bound, right bound, and guess. To do the minimum, we're going to press second trace again. And we're going to choose min. Abby, we did change the window. I don't know if you did that part. Okay. So we'll press second trace. This time we'll choose option 3 for minimum. Now this time, the min is down here. So when it says left of this min, you want to be somewhere to the left of it. Hit enter a couple times, or arrow over. Right of it, go to the right. Hit enter. Again, check your arrows, make sure they're facing in. And then guess you're going to get as close to the min as possible. We should get negative 3.05. Now, for the zeros, I would always check your table first. Okay. So if you press second graph to get your table, now I'm stuck down at 30. You guys probably are too from last week. Remember, if you want to jump up to 0 so they don't have to hit arrow a bunch of times, you can press table set, which is second window, change your table start to be 0, for example, and then go back to your table. Your x-intercepts occur when y is 0. So one of my zeros is 0. See how the y column is 0? We take the x value. You can also scroll around and see if we can find any other ones. And that looks like it's getting too high, so I'm going to have to scroll back down, see if I can find any other ones. There's a chance they're not in my table. And they're not. Okay, but I did get one of them, which will save me like 3 or 4 keystrokes from having to do my zeros. Okay, so this one is in the table, the other ones are not, so let's go back to my graph. So I need to find that one. You can see that it doesn't go through at a perfect point. That's why it's not showing up in your table. So we again press second trace. This time we're going to choose option 0. Second trace. The 0 is actually option 2. Okay. And then we take our cursor. Now when you're looking for the 0, everyone look up here real quick. This is the point you're looking for. So when it says left bound of this point, you need to hit left a couple times or one time. Hit enter. Hit the right button. You're just sandwiching right around the x-axis. Hit enter. And then guess, get as close to that x-axis as possible. Negative 3.65. You do the same thing. We did this in chapter 5. But it was just 2 zeros instead of having 3. Now we have to find out what this one is. You can tell it's 1 point something, but we need to find out exactly what it is. So we press second trace again, option 2 for 0. Take your cursor and bring it all the way over to this 0. Approximately that's where it is. Okay, so I'm going to hit the left key so that I'm to the left of it. Enter, right a couple times, enter, and my guess. 1.65. A lot of button pressing. Sometimes you'll get lucky and all the zeros will be in your table. And then you don't have to do that at all. Sometimes you won't. There should be 3 zeros because it's a cubic function. We'll learn that later in the year, but I'll tell you that now. Now there is a chance you could get just 2, and I think that may happen on this one. Sometimes the graph will come up. It'll come down and like turn around right at the x-intercept, so it actually only touches at 1 point. So typically you'll get 3 of them, but sometimes you'll get like a repeat one where it turns around at that point. Okay, what time do we have? 1:54. We're not going to get through the word problem. So do you want to do this problem or the closure? Did anyone start doing either of them?
I say we do B.
Do B?
Yeah.
All right, let's do B. Type in your y equals. And then you can always restart at Zoom 6, just to give you like a fresh, clean slate. Zoom 6. Did I type that in right? I don't know why I wrote down to change the value then. The window should be fine. I have written down to change the window, but so let's do our max first. The relative max is occurring right here. So second trace, choose maximum, option 4. Okay, we're going to go to the left of the peak, the left of that mountain peak, right of that, and our guess. It should be at 0.015. 0.15. I think I said that wrong when I read it out loud. 0.15. See if you guys can find the relative min and the zeros while I pass out your assignment. I am going to cut off a question from your homework or two because we did not get to the word problem.
Didn't get anything for him, right?
The 14 I know who.
I guess.
Make sure you test number 17 and 39 on the homework.
I got